Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwane. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Our WhatsApp number, as it appears on the screen, it's 079 578 2908. Grade 12, you are more than welcome to send your questions or the clarity seeking question to that particular number. I am repeating it. Please note it down. It's 079 578 2908. Okay. So our topic today is on Euclidean geometry. And then we are looking at similarity, specifically the similarity. And then remember this topic, Euclidean geometry, worth 40 plus minus 3 marks on our paper 2. So we must give it an attention since it is worth so many marks on our paper. All right, without any waste of time, let's begin now. The objectives of today's lessons. After the completion of this lesson, you will be able to apply the following theorems. Equiangular triangles are similar with its converse. Triangles with sides in proportion are similar. And then now, we are going to compare the similar polygons. Remember, when we talk polygons, we are talking geometric figures. It can be a triangle, it can be rhombus, it can be a square, it can be a parallelogram, and so forth. And then now the symbol that we use for similarity is those 3 dashes. Grade 12, do not mix this with congruency. Remember, if we talk congruency, we are talking 3 dashes like that one. So for similarity, we are using that one. Okay. And then what are the conditions to identify whether the figures are similar? And then the 2 polygons are similar if, condition number 1, they must have the same shape, but not necessarily the same size. For an example, it's like we are taking the original diagram that we are having, and then you are enlarging it or reducing the size of the figure you are having. Or it's like you are zooming in and out, the same type of figure with the same values of angles. We are just increasing or decreasing the values of the sides of that particular figure. Then it must be the same shape, not necessarily the same size. And then the second condition, corresponding angles must be equal. As you can see on the quadrilaterals that we are having alongside, we have quadrilateral A, B, C, D, and quadrilateral W, X, Y, Z. And then if you look at the angles inside those particular quadrilaterals, you can see that angle A is 105 degrees, which is equal to angle W, also 105. And then look at B, it's 45 degrees there. And then we have angle X, also equal to 45 degrees. And then we have angle C, 90 degrees there, and then we have angle Y, which is also 90. Lastly, we have angle D, which is 120 degrees, and also Z is 120 degrees. So that is the second condition, greater, that they must have equal angles. And then condition 3, for similarity, the ratio of the corresponding side must also be equal or be in the same proportion. We know that when we talk ratio, we are talking a fraction. And then how do you identify these fractions now? You always start, please, the tip start from identifying the smaller side to the bigger one when you are doing your comparison. And then now let's look at figure 1, A, B, C, D. Which side is the smaller side? That is side DC. So we are going to compare the side DC. Which side is the smaller one on WXYZ? That is side ZY. Therefore, it will be DC over the ZY. And then let's check the ratio thereof. DC is 4, and then the ZY is 40. So the simplified fraction for this will be 1/10. So now let's compare the next one. Remember, we are looking from small to big, right? The side that follows, it will be 8, which is 80. Then it will be 80, followed by the second side here, which is WZ. And then this will worth how much? 80 is 8 over WZ, which is 80. Look at those ratio now. Simplify 8/10. 80 is giving you 1/10. Can you see now you have equal proportions, greater or equal ratios? Let's take the third side now. We are going AB and then correspond with XW on the bigger quadrilateral. And then how much is 8B? That is 11 over the XW, which is 110. And then this is also giving you the ratio 1/10. And then the last side that we have is the BC side, which is the biggest side now. And then it will be the BC over XY. And then what is BC is 15 over the XY, which is 150. So we end up with 1/10. And then the procedure, do not change your procedure. If the numerators, you start from the smaller one, you must always keep it that way. It must be the smaller and then the bigger as the denominator throughout your ratios. And then grade 12, as you can see, this is giving us the same ratio, which is 1/10. Therefore, we can conclude that the polygon ABCD is similar to the polygon WXYZ. Correct? That is how we look at the equal or same proportion. Right, and then what does this theorem state now? The similarity theorem states that if the two triangles, that means in this case we are comparing what? Triangles. If two triangles are equiangular, what do we mean by equiangular? They have equal angles. Equiangular means equal angles. And then if the two triangles are equiangular and then their corresponding sides are in proportion and the triangles are similar. That means now this is the given statement that the two triangles are what? Are equiangular. They have equal angles. If that is the case, grade 12, therefore you can conclude that the corresponding sides are in proportion, therefore the two triangles are similar. And then now we are having the acceptable geometry reasons from our examination guideline 2021, and then it is giving us the correct way of reasoning and the abbreviated reasoning then. Please always use that document with you, grade 12, throughout your geometry. And then now when we are abbreviating this theorem, if the two triangles are equiangular, then their corresponding sides are in proportion and triangles are similar, you can write your reasoning as the symbol of similarity, triangles. Therefore, similar triangles, or you can write it as equiangular triangles. One of the two is more than acceptable. All right. And then you can see that in the diagrams that are given to us, angle A, which is 30 degrees, is all equal to angle D, which is also a 30 degree. Look at angle B there, 70 degrees is equal to angle E, which is also 70 degrees. As I've indicated, it's like we are zooming in or out the original diagram, but it will never affect your angle grade 12. And lastly, we have angle C, which is equal to angle F. Since the two triangles are having equal angles, therefore we can conclude what? Triangle ABC is similar to triangle, and the sequence of angles is very important, grade 12. If you have started with A, you must start with the corresponding angles from the other triangle. So we will start with D here. And then look at B is equal to E, then we will follow with E there, and then C correspond with F, then the last one will be F there. So that will be triangle ABC, similar to triangle DEN. and thereof, grade 12, you can take out your ratios. Remember, we use those eyebrows and smile there, the eyebrows and the smile there. What do we mean about that? If we have AB, it will be AB over the DE. That is the correct ratio. And then if we take BC then, that will be BC over EF. Take out the ratio out of that. The last one will be AC over the DF. The sequence is very important, grade 12. If your numerator, you start from diagram number 1, it must all throughout be diagram on number 1 on the numerators. And then denominator, your second diagram. And then now we have a converse of this particular theorem. And then its converse states that if the corresponding sides now, vice versa, you are now given corresponding sides of the two triangles being proportional. If that is the case, the sides are in proportion, then the triangles are what? Are equiangular and similar. We are reversing whatever we have done previously on the theorem. And then in this case, as you can see, you are given two triangles with the values of the sides now. And then now, grade 12, the reason abbreviated for this converse is that sides of triangles are in proportion, or you can write converse similar triangles is also acceptable there. As your reason. Okay, how do we apply this converse now? It is saying that you are given corresponding sides in proportion. Let's check whether is it true now. Remember, you start from small to big, okay? Now let's check in the smaller. Which side is smaller? It's AB. And then on the other bigger triangle, which side is the smaller one? That is the XY. So we are looking at the simplified ratio of the two. That means AB is 16. We can substitute that. The XY is 32 there. Simple fraction for that is 1 over 2 grade 12. The second side following with the value there, we are having BC from the smaller triangle, bigger one correspond with what? With YZ. Okay, and then giving us the ratio BC is 22 over the YZ, which is 44. Simplified fraction, 1 over 2. And then lastly, we are having what? The AC over the last side there on the bigger triangle, which is XZ. How much is AC? 25 over the XY, which is 50. The ratio, 1 over 2. Can you see grade 12? You end up with the same ratios then. Therefore, you can conclude what? That triangle, remember the sequence is very important. ABC is similar to triangle. You can't just write whatever you want, okay? Remember it's triangle ABC. So the AB side, remember, correspond with what? With the XY. That means here we'll say a triangle XYZ because it must follow the same proportion as the previous triangle. Okay. Now example 1. Is triangle EFG similar to triangle element? And explain. Remember, condition of similarity is that it's either the triangles are equiangular or the corresponding sides are in proportion. And then in this case, we are given the angles. Therefore, we will focus on the application that the angles are equal. Okay, equiangular angles. Let's check now. We are given the angle 80, and then we have angle 80 there, and then we have 30, we have 70 there. So we are short angle F and angle N there. Okay, grade 12. Okay, now we know that in a triangle, if you are given two angles, you can determine the value of the third angle by using what? Sum of angles of a triangle. That means that is the application you are going to take for these two triangles to identify the value of the unknown angle. And then in triangle EFG, so now angle F will be the sum of angles of a triangle, which is 180. And then we are subtracting the given angles there, minus 80 degrees, minus 30 degrees. Why? Because of sum of angles of a triangle. And then this will give us how much, grade 12? That means we are having a 70 degrees there as the value of that particular angle. Okay, and then in the next triangle now, we need angle N. Let's see now. This one is now 70. Let us plug this on. And then in the second triangle, we are looking for the value of angle N. And this will be the sum of angles of a triangle 180. Then we subtract the given ones, which is 80 degrees minus the 70 degrees. Why are we doing that? It's because of the sum of angles of a triangle. You know geometry, for every statement there must be a supporting reason. Okay, and then now this will end up giving us how much, grade 12? The 30 degrees. That means angle N will be 30 degrees. And then now let's check. Do we have equiangular in both triangles? Yes, we have angle E, which is equal to angle L, equal to 80 degrees. That is given to us. Correct? And then condition number 2, we have angle F, that is equal to angle M, which is equal to 70 degrees. We have just calculated above, okay? And then lastly, we are having the last angle, angle G, which is equal to angle N, equal to 30 degrees. We have also proved that on the previous calculation there. That means now if you are talking similarity, you must have 3 conditions, 2, 3 angles that we have indicated equal there. And then we can now conclude that therefore the triangle EFG is similar to triangle LMN. So all the calculation there is explaining why are the 2 triangles equal. What is the condition of being proportional? Is because of equiangular, or you can write angle, angle, angle there. Or you can write equiangular. All right, great jobs. And then in most cases, after proving that 2 triangles are equal, you'll find that the questions that follow, they need the ratio of those particular similar triangles. And then how do we take out the ratio? Let's repeat it again. It will be EF over LM being equal to FG over the MN equals to EG over the LN. That is how you apply the ratios using the proving similarity there. Moving forward, grade 12, next example. In example 2 in the diagram, remember with geometry, you need to ensure that all the information given to you is indicated on the diagram. That is the first thing that you do, grade 12, before you can solve any question. So in this case, we are given in the diagram, AB is parallel to DE. Okay, that is indicated there. And then we have AC is parallel to FE. And we know that the minute we talk parallel lines, we are going to check the condition of the corresponding angles. We have co-interior angles, and then we have the alternating angles there. The minute we are given parallel lines, we know that is the application, grade 12, okay? And then now they say prove that triangle BCA. Let's identify the triangle. They talk BCA, that means they are talking to this particular triangle. And triangle DFE, then we are also talking to the triangle there. So we are going to look at the similarity in those two particular triangles. But before we can do any calculations, let's identify which angle. Grade 12. If you are given these triangles, they are already arranged according to the equal angles for you. Yours is to find the reason why are they equal. Okay, let's identify the specific angles now according to the diagram. If they say angle B, it's only one B there, okay, straight and forward. If they say C, we must be specific because we have that C, another C straight line there. So they are talking to C1 because we are in triangle A, B, C, A, okay? And then which A are they talking to? The A of 80 degrees is only one A, no stress for that one. But remember for C, we will be looking at C1 there. Triangle D, F, E, look at that one. D straight and forward, but F, we are talking to F what? F1. And then E is a straight and forward angle. So that is the first thing that you do. Identify the real angles that you'll be talking to, specifically so. And then from there now, we need to give reasons why are the two angles equal. Okay? Now they say angle B is equal to angle D. Let's see. Angle B is equal to angle D. Yes, they are equal, but the challenge here is that both of them do not have any value. So we cannot rely on that because it is now giving us how many two unknowns. Okay? We'll talk to that later on now. If you don't have values, you move to the next pair. We are having angle C1 equal to angle F1. Let's check. Can we get something that is equalizing them? Okay, angle C1 and angle F1. Yes, at least F1 is having a value there. Then we can take that one. All right, start there. That is the first condition. It will be angle C1 equals to the angle F1, which is equal to what? 70 degrees. What is equalizing them? Is because of the Z shape parallel line. Can you see that? That means we are having alternating angles. Remember, when you reason alternating, you must also give parallel lines where AC is parallel to FE. Grade 12, this parallel is very important. That reason without parallel lines is incorrect. Okay, now we plug in the given the value that we have just calculated, that the C1 is equal to 70 degrees. Moving forward, we have angle A here, which is equal to angle E there. Let's check, can we have a condition that is equalizing them? Angle A equal to angle E. Do we have a reason for that, grade 12? Sorry for that. No, we don't have anything that can take us straight to that. Let's check another alternative that we can take. Look at triangle ABC now. After having the value of C1, can we find B? Yes, because we now have sum of angles of a triangle. In that triangle, we have two angles. We can easily calculate the third angle. Let's do so, grade 12. Let's calculate now. Angle B in triangle ABC, angle B is equal to 180 from sum of angles of a triangle. Then we subtract the 80 degrees for A, we subtract the 70 degrees for C1. Then why are we doing that? Is because of sum of angles of a triangle. And then the B value will be how much, grade 12? That will be a 30 degrees. Okay, happy now. We have the value of that B. We can now go back to B now and check B is equal to what? B is equal to D. That will be our second condition for equiangular now. Angle B is equal to angle D, which is equal to 30 degrees. We have just calculated that. But what is the reason of making B equal to D? Is because they are also alternating. Can you see that shape again? Okay, therefore we have alternating angles, but these ones are alternating between which parallel lines? Between AB parallel to DE. Okay, so that means D is also a 30 degrees. Grade 12, if you have calculated two angles in two triangles and you said these angles are equal, you can conclude without giving any specific reason, just relying on the remaining angles of a triangle. It's obvious now is that in triangle DFE, that E will be equal to A, which is 80 degrees, even if we don't calculate that. Even if we were not having that 80, we can conclude that A is equal to E. Why? Because we already have values of two triangles, angles on those particular triangles that are equal. Obvious, the remaining one must also be equal. So our third condition here will be therefore angle E. Let's check. We started with C, that is the smaller triangle. Here we started with B. The sequence is very important, grade 12. So we have started with C, started with B. That means the third one, we must start with an A in the smaller triangle, which is equal to in the bigger triangle E. Angle E, therefore this will be equal to 80 degrees. The reason will be what? Because of sum of angles of a triangle or the remaining angle of a triangle. So let's apply sum of angles of a triangle. Okay, that means this is also 80 degrees. So we have condition 1, condition 2, condition 3. Then if we have those three, we can now say therefore, yes, triangle what? Same sequence given to you, BCA is similar to triangle DFE. Reason for similarity is because they are equiangular or angle. Okay, can you now take a proportion ratio out of this similarity? Yes, we have BC over DF equal to the CA over the FE equal to lastly BA over the DE. Okay, that comes out of the similarity. And then example number 3. In the diagram, AP is equal to 16. Remember, we are checking now all the given information is indicated on the diagram. So we have AP 16 centimeters, yes. We have PB 14, yes. We have AQ 20 centimeters, yes. We have QC 4 centimeters, yes. We have BC 27 centimeters. Yes, all the given information is on the diagram. We can now address the question. Show that triangle APQ is similar to triangle ACB. So APQ, we are talking to the triangle. ACB, we are talking to the bigger triangle, grade 12. So now the easier way, because we are working with sides now. So we are going to check what? Proportionality, no more equiangular, right? Because we are given sides. Equiangular we use when we are given angles, all right? Right. Now, let's dismantle these two triangles and see exactly what we are talking of, okay? It is easier to compare them if you separate them. So we will be having triangle APQ. That will be your first triangle. And then how much is AP? 16. And then PQ is 18 centimeters. And then the AQ is 20. And then another triangle, we are talking triangle ACB, which is the bigger triangle now. Okay, let's take it out. That is triangle ABC. What is AB? That is 16 plus 14, which is 30 centimeters, correct? And then what is BC? 27. And then what is AC? We are having 24 centimeters for that particular side. Then I have separated the two now, okay? Those are the two triangles we are checking, or we are showing that they are similar. And then we go back to the given triangles that we are proving and identify the actual angles we are talking to. So if we talk APQ, can you see that we are talking to P1 and the Q1 angle there? Okay, with the APC, they are straight and forward. But be careful with P, we talk P1 and Q1 because those are the angles on the smaller triangle. And then the same applies on the given triangle there. If you talk A, can you see A is common? Is the same vertex in both triangles. That is the first thing that you'll be looking at, the common angle A, okay? And then let's look at P. Which P are we talking to? P1 in APQ. Can you see that? Which Q are we talking to? Q1. With ACB north straight, we have only one angle, one A, one B, and one C. No stress with that one. But with the P and Q, you must be specific because we have P1, P2, and then the Q, we have Q1, Q2. So that is why we are indicating that we are specifically talking to P1 and Q1. Okay, great. After analyzing everything now, we can now show that the two triangles are similar. Now we start with AA. We have indicated that angle A will be equal to angle A in another triangle because it's a common angle. They both come from that A point, same point, vertex, okay? And then now the second one, we are testing P1 and C. Let's see now. Okay, sorry, great job. Sorry for that. In this case, we are using proportionality, not equiangular. Sorry for that. Okay, we are using proportionality. Why? Because we are given side. Do not use angles if you don't have angles. They will confuse you more. Right. Remember, our strategy is that we start from small to big side, okay? Or you can start from big to the small side. It depends on you. But stick to one thing so that you don't forget. So you look in the triangle APQ since it's the first one here, and then followed by the triangle ABC. Which side is the smaller one in triangle APQ? That is side AP. Can you see that? That will be AP over the small side on triangle ABC. That is AC. Do you see that, great job? You don't just take any side as you wish. You must follow. Start from small to bigger, right? How much is AP? That is 16. Over the bigger triangle, which is 24 AC. And then the simplified fraction for that is how much, grade 12? That is 2 over 3. Good. And then we take the next side now, the middle one. Check now, we have used 16 and 24 there. The side that will be following, starting from triangle APQ, remember we always start on the same triangle numerator, followed by 18. Okay, 18 is PQ. PQ will be over which side here? BC. Because it's the one with the middle value there then. And then we have PQ is how much? 18. That will be over BC, which is 27. So the 18 over 27, grade 12, how much is the simplified ratio? It is also giving us a 2 over 3. Okay, the last testing, we are taking the largest side now, always starting from APQ. So that will be AQ side over the bigger side from the next triangle ACB. That will be the AB side. How much is AQ? That is 20 over the AB, which is 30. Simplified fraction for that will give you a 2 over 3, grade 12. Can you see that the ratios are equal? Therefore, the triangle APQ is similar to triangle ACB. What is the reason for similarity? What is the reason for similarity, grade 12? We are not talking equiangular anymore because we have checked the side. Therefore, the sides of the triangles are in proportion. Or you can give what? Converse similar triangles. Okay, those are the two acceptable reasons for that. And then from that information, grade 12, please keep on practicing taking out the correct ratios. That will be AP over the AC, AP-AC. The next one will be PQ over the CB, followed by the last one, that is AQ and then AB. I think you are now becoming familiar with that one. Okay, moving forward, example number 4. We are given triangle AEC is similar. It is given to you. You are told that the two triangles are similar now. Triangle AEC, that is AEC is the bigger triangle. AEC is similar to triangle BDC. Okay, and then now show that CD is here, is 7,2 centimeters. And then we are also showing BD is equal to 6 centimeters grade 12. Now, remember we are talking with sides now. We are not talking to equiannular, right? Here we are given sides now. So we are going to use the sides. Remember when you talk sides, we are talking ratio in proportion, right? So we are going to identify those ratios since we are given triangles being similar then. Can we now take out the ratio because triangles are given to us? Yes, we will be having the AE over the BD equal to EC over DC. Lastly, we have the AC over the BC. Those are the ratios out of the given similar triangles. And then let's check now. What do you want to calculate? Number 1, we are looking for the value of CD. Where is CD? There you have your CD grade 12. Can you see that? That means you need the EC over DC ratio. Do we have the value for EC? Yes, we do. That is 12. Can you see that from the diagram? Yes, EC is there. I'm ticking off what I have. Okay. Do we have AE maybe? Yes, we do have AE checking. Which ratio can I take now to solve DC, right? Do we have BD? No, I don't have the value of BD. That means I cannot use this particular ratio now because it's giving me too many unknowns, right? Moving now to the AC and BC, checking AC. Do I have AC? Yes, AC is 9 plus 6. Yes, I do have AC. Do I have BC? Yes, BC is 9. Can you see grade 12? Now we are left with only one unknown, which is DC. Then we go for that ratio, which is having one unknown. So we can now conclude that we are only going to use EC over DC equal to AC over BC. We can now substitute grade 12, right? We suspend that one. We are not going to use the first one. So EC, how much is EC? That is 12. Substitute, then we leave DC because we are looking for that. How much is AC? That is 9 plus 6 from there, which is equal to 15. How much is BC? That is 9. Okay. And then after substitution, grade 12, you now follow what? Cross multiplication. Okay? And then this ratio, remember, it comes from similar triangles, right? And then now let's cross multiply. We are going to cross 9 to 12 then. We'll end up with 12 times 9. And then we cross these two now. 15 down, DC up. So 15 will be the denominator there. Then DC will be equal to 12 times 9 over 15, which is giving us how much? DC equal to the 7,2 that we are looking for. This is initially giving us the ratio 36 over 5, which is that 7.2 centimeters that we were required to show that CD is equal to that. Now moving forward, grade 12, we can plug in DC on the diagram now that we know that the value of the DC side is 7,2 centimeters or whatever. Yes, we are giving in centimeters, 7,2 centimeters. Can you see grade 12? We can also find the value of ED by taking the whole 12 and then you subtract 7,2. Then you will be left with 4,8 for the ED length. Okay, right. And then moving forward now, we want to calculate the BD now. Show that BD is 6 centimeter. BD is on that ratio breakdown. That means we can take AE over BD. We are avoiding this one, or you can use because CD was given to you. But I am guiding you that always use what is given to you rather than the one that you calculated, okay? To avoid, if you go wrong, you will go wrong twice. Ne? Okay, now we take the ratio AE over the BD equal to the AC over BC out of the similar triangle given to you. And then now what is AE? AE is equals to 10. I'm looking for BD. And then AC. AC, remember, is 6 plus 9, which is equals to 15. And then the BC is equals to 9. And then after substitution is the same method. You are cross multiplying 10 times 9 over 15, same way, equal to BD. Therefore, BD will give us an answer of 6 centimeters. Okay, great job. That is how you apply the given similarity to find the unknown side if we are given sides. Moving forward, example number 5. The diameter, remember, giving information into the diagram, we have diameter AME, okay? AME, diameter AME. And then grade 12, if you look at this, we are all having a circle geometry. So your grade 11 circle geometry, it is now infused into the similarity. So now you also need to apply the knowledge that you have from the grade 11 circle geometry into this similarity now. We know that we have a theorem that says that a line subtended by a diameter is equal to 90 degrees, or a line on a semicircle or a line on half circle is 90 degrees. So the minute they tell us that AME is the diameter, that means this angle F now we can conclude is equal to 90 degrees because it is on half circle. Okay, continue. That diameter AME of a circle with center M, it bisects. To bisect it is to cut into 2 equal parts, okay? And then the line AME is bisecting angle FAB. FAB, we are talking to this angle here, grade 12. So if they say this angle is bisected and then A1 is given to you as 40, therefore you can conclude that A2 is also what? 40 degrees because the angle is bisected. Just from that word bisect, it is automatically giving us angle A2. Okay, I am busy plugging in the given information into the diagram. All right. And then they say MD is perpendicular to the chord. MD is perpendicular to the chord AB. That is indicated with a cap of 90 degrees there, grade 12. I hope you can see that one. That D1 is 90 degrees. And then ED is produced to meet circle at C. Okay, it's just the produced line to C. And CB is joined. And then show that triangle AEF. Let's identify the triangles now. They talk triangle AEF. Therefore, this is the triangle they are talking to. And then triangle AMD. AMD. This is the triangle we are talking to. That means now we have now identified the triangles that we are proving similar, grade 12. After that, now, next step, identify the specific angles. If they say AA, which A are they talking to? Because we are having 2 A's there. Okay? Now, in triangle AEF, we are talking AEF is that particular triangle. When they say angle A, they talk to A1. Okay? A1 there. When they say E, they talk E1. And then F is an open one. And then now in triangle AMD, the small one there, AMD, when they say A, they talk to A2, correct? When they say M, they talk to M1 because we are having 2. And then when they say D, we are having 4D angles. So you must be specific that you are talking to D1. That's the first thing you do, grade 12, identify the specific angles. We have done that now. The next step, you check why are those angles equal. Remember, they are already arranged according to equality there. Okay? Now we have angle A1 equal to angle A2. Okay, remember they said they are bisected. That is why they are equal. Okay, we have a reason for that. We can now talk to those angles. Okay, conclude. Angle A1 is equal to angle A2, which is equal to 40 degrees. Why? Because what? AME bisects. It comes from this word bisect, angle FAB. That is the reason that is making the two to be equal. Okay? Testing second angle, E1, M1. Let's see, E1 and M1. Do we have a reason that is making E1 equal to M1 grade 12 that you can think of? No, not for now. So you leave that one. Don't write it down yet. Ne? Check the last angles. We are having F and D1. Let's test F and D1 now. Okay, we have angle F. Okay, remember we said F is 90 because of the diameter. You need to tell us that before grade 12 because that 90 was not given to you. Okay, tell us that now. That angle F is equal to 90 degrees. Yes, because of angle on semicircle or half circle. Okay, after concluding that F is 90, we can now tell us, therefore, this F is now equal to angle D1 because D is given as being 90 degrees. Correct? That is given that D is 90 degrees. That is the second condition. And then remember, grade 12, I said earlier on, if you're having two triangles and two angles are automatically equal, you can conclude that the third angle is also equal. Okay, therefore we will conclude what? The one that we skipped earlier on because we didn't have a specific reason for equalizing, that angle E1 is therefore equal to angle M1 because of the sum of angles of a triangle. Therefore, triangle AEF is similar to triangle AMD because of angle, or equiangular ratios. Okay. Moving forward, here we were infusing the circle geometry into your similarity now. Okay. Okay, grade 12. Yeah, let's continue now. We are looking at the last example 6. All right. And then let's see now. What is this example having for us? In the diagram, triangle M and P. Remember, we are checking the given information into the diagram now before we make conclusions. In the diagram, triangle M and P, which one are we talking to? M and P is the bigger triangle, okay? With R on MP, we have R which is on MP, yes. and T on MN, T on MN is given such that RT is parallel to PN. Yes, RT parallel to PN is indicated there. And then S is a point on PN. Can you see that? S is a point on PN such that the TS is parallel to MP. TS there is parallel to the MP. We are talking to the whole line MP. Great job. Okay, right. And then we are given now MR is 10. Let's check MR 10. Yes, is there. And then we have RP4. Yes, RP4 is there. And then we have MT 8. Yes. And then we have RT9. Yes. We have TNX. Yes. We have SN equal to Y. Yes. All the given information is indicated on the diagram. Happy. And then now we move to the first question. 6.1. Calculate stating reasons. The numerical value of X. We are looking for X here. Okay. But if you look at X, can you see that is the ratio Tn there? Is that Tn? All right. And then look at Tn now, greater. Is touching this parallel line, that parallel line. Can you see that? And then is in the same side as MT there. Look at that. We are trying to identify the parallel lines now for the Tn. Can we go to SY parallel TS? No, because there is another unknown there, Y. So we avoid going that way. We rather go NP parallel to RT. Why? Because this will give us the ratio there and the ratio there. Can you see now we have infused the proportionality now in this one? Okay. Now we can now calculate the value of X now. I hope we are still together. Grade 12s. Okay, now let's start. And then 6.1. We are taking Tn because it's the one that we will be calculating, right? Because it's X then. So it will be X for Tn over the 8mt, which is 8, equal to this Tn. Let's look at this now. This side, it goes this way. It is corresponding with the PR, which is 4. And then look at the MT is corresponding to MR then. That means it will be over 10. And then where does this come from? From the proportional theorem that you were doing last week, grade 12. Prop theorem, or you can say a line parallel to one side. So can you see that there is always an integration in geometry? You can not isolate them. And then we are solving for X. We cross this 8 to 4. It will be 4 times 8 over 10. And then the X value, will be 16 over 5, which is giving us what? A 3,2 units. Okay, great terms. And then now we have calculated the numerical value of X in that case. And then now you can also calculate the value of Y. If we have calculated X, let's see grade 12 now. If X is 3,2, we have calculated that one. Can we also find the value of Y in this case? Can we, grade 12, find the value of Y? Let's see. We do not have that value there, and then we don't have the side there. I don't think it will work for us for now. Okay, let's just go to the next question there. What type of a quadrilateral is RTSP? And then since these lines are parallel here, and then both pairs of opposite sides are parallel, therefore that is a parallelogram. And then you can see, grade 12, that this shape is skewed. It cannot be a rectangle, because rectangle, it must have a 90 degrees angles at the corner there. So this one qualifies to be a parallelogram, since the sides are not equal. If sides were equal, we will say it's a rhombus. But in this case, it's like you're taking a rectangle and then you stretch it like that, then it will give you a parallelogram. Okay. And then now we can now calculate the value of y. Since we have concluded this is a parallelogram, that means if it is 9, this will also be 9 because the opposite side of the palm are equal. Can you see that, grade 12? And then we have calculated the x here and say x is equal to 3,2 from our previous calculation. And then now, hence, they say calculate the numerical value of y now. Can you see now you can now calculate y because we now have the value of PS, which is 9. And then which parallel lines, grade 12? The y taking you to that line. And then now, please identify the lines. This parallel line goes to T, and this one of P, it goes to M there. Then they are now creating that particular triangle that will be working in. Therefore, this way we will be going that way using the proportionality there. So that means it will be y over 9 equal to the x. Remember, this is corresponding to this side. Tn, therefore y correspond with 3 over 2. And then now the 9 will go with an 8 there. Then that is out of the line parallel to one side or the proportional prop theorem. That is our reason. According to the correct acceptable geometric reasons. Therefore, y will be equal to 3,2 times 9 divided by 8, which is giving us how much, grade 12? The y value. And the y value will be 3,6 there. So y will be 3,6 in a simplified decimal form there. Okay. And then now, grade 12, let's move on to the next question now. Number 4, let's put in the values first. We have calculated that as 3.2 and the y as 3.6, and then PS is opposite to that one, parallelogram 9, and this ST will be 4. Okay, that is what we have from the previous calculation. So it is very important, whatever you are calculating, plug into the diagram. Okay, and then in 6.4 now, we need to show the triangle MRT. MRT is similar to triangle TSN. MRT, we are looking to that one, similar to TSN. So we are comparing these two now. Okay, we do not have angles, grade 12. We are given the sides in proportion. Okay, let's start with the sides, with what we know first. Okay, all right. And then now, remember, I said to you, you can separate the triangles, but with this one, it's easier to identify because they are already at the different position on your diagram. So let's start now. Which side is the smaller one in TSN? Or the first triangle is MRT. Let us stop, avoid confusion. MRT, which side is smaller? That is MT, okay? Over smaller side on TSN, TSN. The smaller side is 3,2, which is TN. So this will give us MT8 over the 3,2 of TN. And then the simple fraction for that will give us how much, grade 12? We are having a 2 over 5. We are checking ratios now. Okay? And then now, starting from MRT again, starting from that one, the next will be 9, which is RT, over in triangle TSN, the next side will be 3,6, which is SN. Therefore, it is giving us the ratio 9 over 3,6. And then the simple fraction of that, grade 12, please check with me also. We are having what? A 5 over 2. I think it's 4. Let me verify this. Is it 2 over 5 or 5 over 6, grade 12? Are we still together? For the first one, 8 over 3,2. Let's check. It's 5 over 2. 5 over 2. Okay, 5 over 2. And then the next one also we have 9 over 3,6 then. How much does it give us? A 5 over 2, also grade 12. Okay, sorry for that. And then the last ratio now. Which side is remaining? Which is the largest one? That is MR. Over the largest side on TSN. TSN, the large side is 4, which is TS. MR, how much are you? 10. And then the TS is 4. And therefore, this is giving us the simple ratio, which is 5 over 2. Can you see grade 12? We have 3 equal ratios there. Therefore, we can conclude that what? Triangle MRT is similar to triangle TSN. Reason being, sides of triangles in proportion. Okay, let's say now one learner decided to check the angles and give us reasons. Let's see whether can it work for us. We have angle triangle MRT. Let's say we are having R1 there, R2, T1, T2, T3, and then we have S1, S2 there. And then when you talk M is straight, only one M. And then when you talk R, we are talking R1 there. When you talk T, we talk T1. Okay. And then when you talk TSN, let's see, T is T3. And then S is S2. And then the N is straight N, like that. Okay. So now we want to check. Can we use angles being equal there? They say, let's check angle M. Can M be equal to T3? M equal to T3. Can we take that? Yes, because we have parallel lines there. Therefore, these are angles inside F, corresponding angles. Okay, we can have the first angle M is equal to angle T. Why? Because corresponding signs, because of corresponding angles, okay? Where PM is parallel to the ST. Can you see those parallel lines later? Yes, therefore this angle is equal to that one. And then let's check condition 2. R1, S2. Can R1 be equal to S2? Let's see. Oh, R1 can be equal to this one, T2. Can you see that? That's that shape of alternating angles. And then T2 is also equal to S2 because it is alternating from that point to that one. Okay, we can start there, go and end up being an S2. Okay, that is condition number 2. That is R1 is equal to T1 because of the alternating angles between which parallel lines, that is PM, parallel to ST. Therefore, also T2, sorry, that is T2. T2 will also be equal to S2. Angle T2 is equal to angle S2. Look at that, they are also alternating then. Angles between which parallel lines now? RT parallel to PN. Okay, since these angles are both equal to T2, therefore we can conclude that angle R1 is equal to angle S2. R1 equal to S2. For number 3, we don't even check what is happening. Therefore, we can conclude that also T1 is equal to angle N, sum of angles of a triangle or the remaining angles of a triangle. So therefore, triangle MRT can be also similar to triangle TSN, applying what? Angle for the alternative solution there. Okay. Grade 12, can you see that we have infused in the proportionality now into our activities? And then now, without any waste of time, I want you to do activity 1 for me. In the diagram AB parallel to DE, AE and DB intersected C. A is 47, C4 is 91. Show that triangle ABC is similar to triangle ECD. 3 minutes, grade 12. Your 3 minutes start now. Okay, grade 12, let's check how far did you go with this one. Remember our WhatsApp group. If you need clarity, please send your question or your clarity seeking question to 079 578 2908. Okay, right. We were given 47 degrees for A1, C4 91 degrees. We are given parallel lines as indicated on the diagram. So we need to show that triangle ABC is similar to EDC. And then grade 12, you are given angles. Therefore, your application will be what? Equiangular, right? You'll be checking angles, working with angles to prove this similarity. Remember, you need to identify the angles now. If they talk A, they are talking to A1. If they talk B, that is B2. If they talk C, that is C3 in triangle ABC. So in triangle EDC, if they say E, they talk E5. If they say D, they talk D6. And then C, that is C4. Okay. Yours is to find out now, can you equalize those angles according to the sequence given to you? Is angle A1 equal to E5? What is the reason? A1, E5. Yes, can you see that Z shape? Therefore, they are alternating, right? Therefore, A1, that is the first condition, angle A1 is equal to angle E5. Yes, they are both equal to 47 degrees, the reason being alternating angles, where AB is parallel to DE. Already given to you, grade 12. Therefore, this angle will be 47 degrees. Now we test number 2. B2 and D6. B2, D6. Can you see this 2? We don't have values there. Therefore, we cannot go straight there because we will have 2 unknowns. Let's check. Can we do something maybe to find the value of one of the 2 angles? Yes, we can calculate D6 because in triangle DCE we already have 91 and 47 there. So we can use sum of angles of a triangle to find what? Angle DC. Let's do so, grade 12. And then DC now is equal to 180 degrees from sum of angles of a triangle. You minus 91 degrees, yes, minus the 47 degrees, yes. Where does it come from? Sum of angles of a triangle. And then how much is D6 now? The D6 will be equal to 42 degrees, grade 12. Okay, we can now plug in the 42 degrees there. All right. Can we now talk to B2 equal to D6? Yes. Our condition now will be B2. That will be our second angle. Remember, we started with that one. When we talk similarity, this will be our second pair. That will be B2 is equal to D6, which is equal to 42 degrees. What is making them equal is because they are also alternating. Can you see that Z shape? Therefore, alternating angles where AB is parallel to DE. Happy, grade 12. We are looking for the third condition now. Remember, we said if only 2 is equal, we can conclude the third one is equal. Or you can tell us, we started with A and then B, we now talk C3. Ne? If we start in that triangle, you must stick to the pattern. So it will be C3, angle C3 is equal to angle C4, which is equal to 91 degrees. What is making this equal? You can talk vertically opposite angles, or you can just tell us it's because of sum of angles of a triangle, because that is the remaining angle in both triangles. Okay, then we have 3 conditions. Therefore, the triangle ABC, follow that sequence, is similar to triangle EDC as it was given to you initially there. And then what makes this similar is because of the angles. Angle, 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 or because of equiangular. Okay. And then from there, grade 12, remember you can take out your ratios now. If the 2 triangles are similar, we can have the ratio AB over ED equal to the BC over the DC equal to the AB smile over the EC smiling there. It's eyebrows there and then your smile there. Okay. And then now move on to the next question. Okay, let's continue now with the activity. Yeah? They say determine the length of BC if you are given AB 6, DE is 8, and the DC is 12. Remember, you have ratios from the previous calculation that AB is over the ED, which is equal to the BC, out of the similarity, remember, over DC equal to the AC over the EC. And then now, grade 12, do you still remember the tip around this? You check, or AB is given there. Okay, you have AB, you have DE, yes, you have DC. And then you are calculating BC. It is already channeling you which ratios to choose. So you will be relying on these ones. We ignore that one because it is causing now 2 unknowns. Okay, substitute AB 6, ED 8. The BC is what we are looking for. And then the DC is 12. Okay, and then BC cross multiply. It will be 6 times 12 and then divide by 8. Okay, and then this is giving us how much? The 9 centimeter then. That is the value of the BC set. All right. And then activity 2 now. I am also giving you 3 minutes, grade 12, to work on those 2 questions there. Your 3 minutes starts now. Okay, grade 12, let's see how far did you go with this one now. The diagram shows triangle ABC, which is the first triangle here, and then triangle DEF, which is that particular triangle. And then determine the sizes of the remaining interior angles of the 2 triangles. Remember, it is very easy. If you have 2 angles, you can use sum of triangle to find the unknown one. So let's start. It's starting triangle ABC. Our unknown angle there is C. So angle C will be equal to 180 degrees. Then we subtract the given angles. We are given 111 degrees minus the 32 degrees. Where does it come from? Sum of angles of a triangle. Application. Right. And then now 180. And then we are subtracting the 111 and 32. Therefore, C will be how much? 37 degrees. So we plug in 37 degrees there. Okay. And then now we are answering 2.1, remember, where we are determining the sizes of the remaining. And then in triangle, DEF, the unknown angle there is E. And then to calculate E, we are taking sum of angles of a triangle. Then we subtract the given angles, which is 32 degrees, and the 37 7 degrees. What are we applying? Sum of angles of a triangle. And then 180 minus 32 minus 37 degrees, it is giving us how much? 111 degrees. Therefore, the angle E will be 111 degrees. Can you see the link, Rachel, the pattern in your triangles? Yes. And then now let's move on to the next question now. You're looking at 2.2. 2.2 is stating that show that triangle ABC is similar to triangle EDF. Okay. Can we use side grade 12 proportionality? No, because we have unknowns on our side, X and Y. We don't know the values of those particular sides. That means you cannot apply proportionality, because for proportionality, all three sides must be in proportion for the two triangles to be similar. So we can't go this way, that way, because there are unknowns. Okay. So we are opting for what? For using angles. Equiangular, because angles are given to us and we can see that they are automatically equal. Okay, now let's start. We are starting in triangle ABC. We can say angle C is equal to angle F, which is equal to 37. We have just calculated that. Okay, and then the next angle, we are having angle B. Remember, the sequence here is already telling you that A is equal to E, B is equal to D, C is equal to F, correct, grade 12s? And then C is equal to F, and then we started from here, C to F, and then we took BD. B is equal to D. Everything is given to you. Yours is just to verify. Can you see that they are equal? And they are also following that sequence on the given information. And then that is given being 32, 32. Okay? And then lastly, we are having angle A, which is equal to angle E. Look at A now. A equal to E, which is equal to 111. We have just calculated that. Okay? Then the three angles are equal. Therefore, triangle ABC is similar to triangle EDF. And out of that, grade 12, we can also take the proportionality. You have your eyebrows there. Therefore, it will be AB over ED over and then BC over DF equals to your smile AC over EF. AC over the EF. Okay. And the reason for similarity is always angle for this case, or it is equiangular because we were talking to angles. Okay, moving on. And then now, hence, determine the numerical values of X and Y. And then now, remember, we have just proven that triangle ABC is similar to triangle EDC grade 12. Okay? And then we have identified that we can take out the ratio AB over ED is equal to the ratio BC over DC equal to the ratio AC over EC out of the similar triangles again. Okay? And then now let's check now. Okay, what do we have in order to solve for X and Y? Check. AB, do we have the value of AB? AB is X. Can you see that? AB is X. And then do we have ED maybe? Yes, it's 4,74. Do we have BC? BC 25,69, yes. Do we have DC? It's A, B, C, and then E, D, C. So it's ED. That is EDF, sorry. Is it EDC, EDF? Sorry, grade 12 for that. Our triangle is EDF. Okay, that is why it's confusing now. It's AB, yes. Eyebrows AB over ED, yes. ED. Let's rectify this. BC, yes. Over the DF, ne? DF for that one. And then we have a smile AC, yes, over EF. Correct, yes. Now let's start again. AB we have as X, ne? And then we have ED 4,74. Yes, we do have. Do we have BC? Yes, BC is 25,69. Do we have DF? Yes, 7,36. Therefore, we can rely on this to find the value of X. Can you see that, great job? Right, let's start with the X now because that is the way, okay? And then AB is X substitute now. And then the ED is 4,74 from there. And then now equal to the BC. There is your BC 25,69 over the DC, the DF 7,36. Okay, and then from here now we can cross multiply. You know, that is the norm now. We are dealing with fractions, there will be cross multiplications everywhere. 25,69 crossing that 4,74 times 4,74 divide by 7,36. So our X value here will be equals to how much? 16,54 grade 12. That will be your X value when you simplify that fraction. Now we do have X is 16,54. And then now we want to calculate the value of Y. Let's check now. How are we going to get Y now? Y is EF. That means Y is EF. It's here. And then do we have AC? Yes, AC is 14,58. Can you see that, grade 12? Now we can now take these two ratios here to find that one. Okay, we are going to use BC over DF equal to the AC over EF. And then let's substitute now. How much is BC? 25,69. And then how much is DF? 7,36 equal to the AC, which is 14, from the 58 over the EF, which is Y. Okay, then we are crossing Y to that point. There it will be Y. And then we take 25 down there. Okay, that will be 25,69 denominator there. Correct? And then now we are crossing 7,36 to 14. Then it will be 14,58 times the 7,36. Straight into your calculator, grade 12. Therefore, your Y will be how much, grade 12? Simplifying that fraction, that will be Y equal to 4,18. So basically, those are the expected values for our answer there. Okay, move on to the last activity now. Can you try that one, grade 12, within 3 minutes? I'm giving you 3 minutes to do that one, starting now. Okay, grade 12. Let's see how much have you collected. Right, you consider the diagram given to you on the right hand side. And then the first question says that name with reasons two other angles that are equal to 25 degrees. I hope now, grade 12, you are now familiar with this. Can you see those parallel lines? Yes, now they are forming that Z shape that we were talking to earlier on. Therefore, this is creating alternating. Therefore, angle E1 will be equal to angle A, which is equal to 25 degrees. Because of what? Alternating. Remember, for every statement, there must be a reason in geometry. Ne? Alternating angles between parallel lines AD parallel to EF. Without parallel lines, the reasoning is incorrect, grade 12. Happy now? A is equal to 25 degrees. But look at that A now. It is now leading you to C. Why? Because you have that bow tie shape. Can you see that, grade 12? You have your bow tie shape there. That means it is giving you angles on the same segment. Reason. Okay, from your circle geometry there. Therefore, angle A is equal to angle C. Therefore, this will also take a 25 from what? Angles on same segment. Okay, those are the two angles that we were looking for there. Now move on to 3.2. Show that triangle FCE. Which one is FCE? FCE, we are talking to this triangle, grade 12. Is similar to FEB. Similar to that one. Okay. So we need to identify. They say FF. Can you see F is shared by both triangles? That F lies on this triangle here. It also lies on the bigger triangle. So it's where you are having F equal to F, which is a common angle. So in most cases, you will be having this common angle. Not always grade 12, but in most cases, right? Now we have identified FF is equal. Let's see now C. In FCE, the bigger triangle C, they are talking to this angle here. They say this C is equal to E. Is it true, grade 12? Yes, we have just proven above that C is also 25. Therefore, angle C will be our second angle here. Angle C is equal to angle E. Which E are we talking to in this triangle? That is E1. We are talking E1 there. This is equals to 25 degrees. That is proven. We have just shown that C is 25 above there. And then now we have the third angle, the last one, we are talking E. Which E now in the bigger triangle? We are talking the whole of E, which is 1 and 2 for FCE. And then they say is equal, must be equal to angle B in the smaller triangle, this one. Therefore, we are talking B3 there. Remember, if you have two angles equal, without stressing about the reason, you can conclude the remaining is equal. So we can just say, therefore, angle E1 plus angle E2 is equal to angle B3. Because of what? Sum of angles of a triangle or remaining angles of a triangle. Therefore, triangle FCE is similar to triangle FEB. Thank you very much, grade 12. This brings us to the end of today's session. And this session was brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center, and it was broadcasted by the Phagama Research and Development. Enjoy your long weekend. See you next time. Thank you very much.